All right. I'm a 90s kid, so one of the experiences that made me fall in love with gaming was Super Mario 64. The ability to move Mario through a 3D environment was a level of immersion that I never experienced before on Super Nintendo games. What I didn't appreciate at the time was that gameplay mechanic was only made possible because of an innovation in input technology. The Nintendo 64 was the first console to ship with a controller that replaced the four-directional D-pad with a 360-degree joystick. And that one input technology innovation opened up gameplay that enabled 3D games like Mario, like Zelda, Ocarina of Time, and GoldenEye. Every time there's a new breakthrough in input technology, new gaming possibilities open up that move the industry forward. My name's Colin. I'm a PM at Meta, and for the last 4 years, I've been working on our input and interaction technologies. And today I want to talk to you about one of those input innovations, hand tracking. Over the last 4 years, I've been able to watch hand tracking evolve from a niche new feature on Quest to one today that's used actively by over 50% of our Quest 3 users on a monthly basis. And we expect that hand tracking will play an increasingly big role in the future of the XR ecosystem. So I'm going to talk to you about, one, how should you decide whether hand tracking is a fit for your app or game? Two, some of the best practices for designing for hand interactions. Then we're going to pass it over to Samuel, who's going to talk about his experience implementing hand tracking in Maestro. So when building any type of game or product for that matter, the first thing you should think about are who are your customers. On one end of the spectrum, you have core gamers. For core gamers, using a gaming controller is like an extension of their hands. These gamers appreciate games that are challenging and complex, and those types of games tend to benefit from the input and reliability and precision that you get from controllers. On the other end of the spectrum, you have casual gamers. Casual gamers tend to spend the majority of their gaming time on mobile, and some of them have limited or no experience using gaming controllers. For them, using hand tracking is more natural and more intuitive. There are some games that are able to bridge that gap and appeal to a mix of core gamers and casual gamers. And for those games, supporting both hand tracking and controllers can help them bridge that chasm to appeal to a wider audience. Once you've decided who you're building your game for, the next thing to think about is what is the unique value proposition that you are offering to those gamers. Some gamers are looking for a challenge. For these gamers, if they don't die many times while playing your game, it's because you didn't make it hard enough. That's one of the advantages of controllers. You have near 100% input reliability, compared to hand tracking, which is somewhere in the ballpark of 97%. That 3% difference doesn't matter a lot for many games, but if that boss is running at you with an axe, that 3% difference might matter a lot. But hand tracking has its own unique advantages. One of them is social presence. Studies showed that over 50% of communication is nonverbal, and hands play a big part of that. So if you're building an experience where social is a key part of your unique value proposition, then hand tracking is going to offer the best experience. Another advantage is comfort. Holding or being hands-free is just more comfortable than having to grip a controller for an extended duration of time. So if you're playing like a slow-paced game like poker, the difference may be, for a user of like a 20-minute session with controllers or a 60-minute session if they can be hands-free and they can be multitasking while they're waiting for their turn. They can be eating snacks. They can be checking their phone. And then one great option is instead of you making that trade-off decision for your users, is supporting both and letting your users choose how they want to make that trade-off decision about what characteristics of their inputs appeal to how they want to play and what they want to get out of your game. Next, there are some specific gameplay interactions that are better suited for either controllers or hands, and I want to call out a few of these. First is sliding locomotion. The controller joystick was built for sliding locomotion. While hands, we have come up with great ways to do teleport locomotion with hands. We just don't have like a great way of doing a joystick-based sliding locomotion mechanic with hand tracking. So if you're building a game that has a hard requirement on things like platforming, you're better off focusing on controllers. The second is shooters. A VR controller was designed to be like a gun. Your index finger is resting on a trigger, and you benefit from the haptics that you really feel when you're pulling that trigger. So if I were building a shooter in VR, I'd focus on controllers. Third is out-of-range motions. Controllers have IMU sensors that allow us to have a sense of where the controllers are, even when they're outside of the tracking range of the cameras on the headset. For most games, this doesn't matter, but there are some games with mechanics like an over-the-head football throw or a golf swing, where having those IMU sensors are important for those types of out-of-range swinging mechanics. There are specific interactions that work better for hands. One of those is physics-based hand interactions. Because with hand tracking, you can have fully articulated fingers that opens up some object manipulation use cases that are only possible with hands. Hands Physics Lab is a game that has some good examples of those. Another are surface interactions. If you're building a mixed reality game and you're using scene understanding, and you have awareness of where the surfaces are in the user's environment, you can overlay virtual content or buttons on those surfaces and allow the user to use hand tracking to poke those buttons on the surfaces. That provides some real-world tactile sensation of poking that you don't get when you're putting floating objects in the air. The third are gestures. Hands can do gestures that controllers can't do. And that can be a good fit for a lot of different types of games. Sam's going to talk about some of the gestures they built for Maestro when we get to his part of the presentation. If you take all those considerations together and put them into a Venn diagram, you'll get something that looks like this. If you ask AI to slopify that slide for you, you'll get something that looks like this. A lot of games, when I joined Meta, were in this right side of the Venn diagram, built exclusively for controllers. Over time, we've seen more and more games that are finding success building for controllers and hands, and even some building for hands. We expect that trend to continue over time. But I do want to emphasize one point, is we do not think controllers are going away in VR. Like I talked about before, there are certain types of games that are not a good fit for hand tracking, and controllers will always be the best way to experience those games. So now you know whether hand tracking might be a good fit for your game. Let's talk about some of the best practices for designing your interactions for hands. First one, differentiate some, standardize more. Gaming is a competitive market. The only way a gamer is going to choose your game over the thousands of other games that are available to them is if you are differentiated in some unique way. There are lots of different dimensions that you can choose to differentiate your game on. Maybe the visuals, or the story, or the puzzle design. But one common way that developers differentiate their VR games is with their interaction design. But you need to be really focused about which interactions you choose to focus your attention on and differentiate. Let's imagine I'm building a VR game for Ultimate Frisbee. I'm going to spend 90% of my time focusing and iterating on the interactions for throwing a Frisbee and for catching a Frisbee. And I'm just going to standardize and apply best practices to everything else. When I launch my game, I want to make sure I have the best throwing and catching interactions that the VR industry has ever seen. A big mistake too many developers make is trying to differentiate too much and innovate across too many different dimensions. Game developers, and especially VR game developers with small teams, tight budgets, don't have the luxury to innovate across every possible dimension. You have to choose your battles, and you need to be thoughtful about where you want to differentiate and then apply best practices to the other elements of your game. At Meta, we're trying to make this as easy as possible for you, and one way we do this is through our work on the Interaction SDK. This is a library of interactions available on Unity and Unreal that developers can easily pull into their applications to get best practice core interactions like raycasting, grabbing objects, poking buttons, locomoting. One thing I've heard over the years from developers is I really like the Interaction SDK, Colin. You have great quality interactions, but I need my app to work cross-platform, and I don't want to take a dependency on something that's Meta-specific. I totally hear you. That's why about 18 months ago, we launched our Interaction SDK Essentials package, where we stripped out all of our Meta platform dependencies so that now you can benefit from high-quality iSDK interactions while also supporting other platforms off of Quest. There's one type of interaction that rarely makes sense for developers to reinvent the wheel on, and those are your UI and menu interactions. So one sample we have in the Interaction SDK, we call the UI set, which is available on Figma and Unity, that provides a whole bunch of different UI components with every type of different possible UI interaction that you might need that you can pull into your app to easily build your menu interactions. All right, 2, lean into embodiment. Embodiment is the superpower of VR. That is why a gamer chooses to put on a Quest headset instead of picking up an Xbox or PlayStation controller. They want to actually feel like what they're doing in their immersive game. I want to talk about one case study for a developer who leaned into embodiment. This developer noticed that there was one interaction that the VR industry had kind of standardized around that was not embodied, and that's using your joystick for locomotion. That's been a standard ever since Super Mario 64, where console games have been using that joystick to move the character forward. But in VR, it just doesn't land the same because it's not embodied. So this developer, they invented a unique and novel mechanic for using your arms against the floor to move your character forward. You may have heard of this. This one game and this one interaction innovation where they leaned into embodiment sparked a revolution in our industry. Now dozens of successful games have gone and implemented a similar mechanic in their game. We also, in Interaction SDK this year, we launched our own sample of our own flavor of kind of physics-based locomotion with hands and controllers. If you're curious, come by our booth this week and you can come try it out. My point here is not to say that every VR game should be using Gorilla Tag style locomotion. You should be thinking about your game and your users and consider what are the use cases and interactions where you can lean into embodiment to provide a more immersive experience for your users. Some examples here might be using your hands to reload a gun instead of just pressing a button. Physically opening a treasure chest instead of pressing a button. Reaching out, grabbing a steering wheel and steering instead of using a joystick for steering your car. All right, 3, use affordances to drive immersion. Affordances is how we trick users' brains into feeling like they're really doing something that they're only doing virtually. And we have 3 tools in our affordance toolkit to drive this sense of immersion. Those are visuals, audio, and haptics. With hand tracking, you don't have haptics. You only have visuals and audios. That means it's really important to get those visual and audio details right when you're designing your affordances to make sure that users have a magical immersive experience. I'll give a couple of examples here. One is a feature in ISDK that we call touch limiting. This is where you diverge the user's real hand from their virtual or synthetic hand when they're poking a panel or a 3D virtual object. In this case, your virtual hand is going to be pinned and stop at the surface of the virtual content, and that's tricking the user's brain into feeling like they're actually poking it. There's also some subtle other visual effects, like a cursor that gets kind of brighter and more condensed as the finger gets closer to the panel, and sound effects that round out and make sure that this experience is magical and immersive as possible. The second example that I'll give here is hand grab poses. This is where you're overriding the virtual hand's joint positions to more naturally grab objects. In ISDK, we have tooling to help developers record hand poses for each object, so it tricks the user's brain into feeling like they're actually grabbing and pulling the trigger on that spray bottle. So those are some of my best practices. I want to also share that this is just the tip of the iceberg when it comes to some of our best practices for designing for VR and for hands. And we have a whole section of our website under the design ribbon that has dozens of pages of design best practices and guidelines for designing for hands and for other inputs for VR. So if this is interesting to you, you want to go deeper, please check that out. All right, now I'm going to pass it over to Sam to talk about his experience implementing hands in Maestro.
Hi. Thanks. Hi, everyone. My name is Samuel. I am the lead developer at Doublejack. I've been doing things in Unreal Engine for roughly 10 years now, and I'm going to kind of talk about how it was to implement hand tracking in Maestro. So if you haven't heard of it, Maestro is a VR orchestra conductor game where you play as an orchestra conductor, and you get to play pieces like Mozart, Beethoven, but also Game of Thrones, Star Wars, and Lords of the Rings. So I'll quickly show you an extract from our latest release. It's a pirate-themed DLC with songs of, well, such as the Pirates of the Caribbean. Okay, so when we started development on Maestro, hand tracking hadn't been released yet, so we were prototyping with motion controllers. But as soon as we could get our hands on it, we of course had the discussion of whether or not it was a good fit for Maestro. So I've kind of broken down the reason into three categories. The first one being, does it fit your fantasy? For Maestro, well, real conductors don't have motion controllers. And actually, if you ask anyone to mimic an orchestra conductor, they'd probably just wave their hands in front of the headset, which is exactly what we wanted to implement. As an added bonus as well, we noticed that hand tracking was robust enough for us to allow users to hold a baton or a fork or chopsticks or whatever, just a prop that kind of adds to the immersion. The second question is, does your gameplay support it? Again, for Maestro, our gameplay was mostly gesture-based. We were only looking at the handle location, so we could just replace that with wrist location. Over longer play sessions, like 20 minutes, half hour, we noticed that there was less arm fatigue. Obviously, in a game where you just wiggle your arms around, it's important. And finally, we were representing the motion controllers as hands anyway in the game, so that was a no-brainer. And finally, yeah, as Colin said, it's just easier. Being able to just chuck on the headset and pinch your way through the game is easier for the player, it's easier for the developer. So that was a great bonus for us. And yeah, sorry. And there's a stronger connection between your hands and the gameplay because there's one less abstraction layer. The user doesn't have to learn how to use the controller. So all in all, we believe that hand tracking was not only a good fit, actually enhances the experience of playing Maestro. And nowadays, we pretty much only use it, and we use motion controllers just during our QA passes. So if you do decide to implement hand tracking in your games, one of the first questions you'd probably ask yourself is, how different is it than working with motion controllers? And what does it mean in terms of data? So with both hand tracking and motion controllers, you'll get a root transform, so that's your wrist location or the handle location. They're not exactly the same, but you can offset the one to get the other. For hand tracking, you'll obviously get 26 bones per hand, so you can animate a mesh, you can do some input detection, but if you're starting out, you can just use the Meta SDK hand component, which will animate the hands for you and display meshes. With controllers, you'll get 6 touch buttons and 1 analog stick per hand. And for hand tracking, this is where it gets kind of tricky, because you will get a pinch value for each finger, so that's between the thumb and each of the 4 other fingers. You will get the system inputs, so that's when your palm is facing ahead and you pinch, you got 1 for each hand. But if that's not enough, you will need to look into gesture or pose detection. So overall, there's a lot of data. It's quite similar to motion controllers. But for Maestro, we did need to go into pose and gesture detection. Now, if you're starting off, again, I do recommend checking out the Interaction SDK. It will, among other things, allow you to record gestures and have the SDK detect it for you. But when we started building Maestro, we didn't have access to these tools, so we kind of went down the custom DIY solution route. So we designed a system where we can define gestures as a list of conditions. And the workflow is divided into 3 steps. So you've got the first step, which is defining your gesture. So this can be your hand pointing forward, it could be your hand moving up, it could be your fist closing. Yeah, it can be anything. The second step is then to look at the data and break the gesture down into conditions. So conditions can be the hand velocity direction, hand position. Is it in front of you? Is it above your head, below your head? Could be finger poses. Again, there's a lot of different conditions you can implement. And finally, just test and iterate. There's a lot of things you can do, so there's a lot of playtesting time. One example of this is our palm up and palm down gesture. So we needed a gesture to make the orchestra stand up or sit down. So we actually have 2 gestures here. So it's palm oriented upwards and the hand moving up, or palm oriented downwards and hand moving down. There's 3 conditions. It's quite a simple gesture. Got palm orientation, got hand velocity, making sure it's going in the right way. And then we've got the hand distance threshold. So that's just checking that the hand distance travel, sorry. So it's just checking that the hand has traveled enough distance to trigger the input. Another example of this is the bow down. Here, it doesn't involve any hand input, but it just serves as a reminder that you can combine different inputs to create a more immersive experience. Here, the 3 conditions are only using headset data, so HMD rotation and yeah, that's it. So yeah, making sure that the user is facing the audience, making sure that the user is looking downwards, and then just a generic condition that ensures that the 2 previous ones are valid for X amount of time. Now, if you're working with hand tracking, there are some limitations to be aware of. The first one is that hand tracking works by having cameras look at your hand. If the cameras don't see your hand, you won't get any hand tracking data. So that's dramatically improved over the years, and I should say without us having to do anything, so that's awesome. But yeah, this poses a good example of this improvement. Back in 2021, so yeah, in Maestro we got this gesture where, well, we got this mechanic where we asked the user to double tap the podium with its baton. Back in 2021, the hand would be in such an angle that the fingers wouldn't be visible, and the hand tracking would just lose tracking of the hand. Now you can see in 2025, it's all working fine. And you can even see when I open my palm that the finger gets picked up very fast, so it's quite responsive. So the takeaway for this limitation is just to always keep in mind the perspective of the headsets cameras on your hands and favor mechanics where your hands are in front of you, in the FOV of the cams. Another limitation would be linked to fast movements. So in a gist, the faster you move your hand, the less accurate hand tracking finger tracking becomes. So I would recommend avoiding asking the user to perform hand poses while moving your hand fastly. And I would recommend as well, instead do making sure that your hand is moving slowly or coming to a stop. An example of this gesture is our fermata mechanic, which for the law is an indication to some musician to stop playing. We've got the hand moving fast in front of the headset and the fist closing. This is a great pose because it leaves enough time for the cameras to pick up your hand and pick up your fingers and detect it. So yeah, takeaway is avoid implementing mechanics that expect specific finger pose in addition to fast movements, and instead favor slowly moving or static hands. This gesture would be very difficult to implement. Now, another important changes when switching to hand tracking is user interfaces. Now, just like in a regular VR game, you've got 2 main ways of doing interfaces. You've got the floating window method. So this is where you've got a 2D floating interface and you interact with it by aiming and pinching. This is probably the quickest way to implement your interface because it allows you to use your box standard 2D interface. It's therefore easier to maintain and it can usually contain a higher information density. However, it's quite reliant on the user skills to aim and pinch. which is not innate in everybody, especially in new users. And depending on your design, it can be quite immersion breaking. The other method would be the diegetic or physical interface. So that can take many forms, but it's usually revolves around the user interacting with physical objects in the environment to navigate the UI. Now, straight out the bat, this is the easiest to get wrong. So it will need more design time and more playtesting time. But if done right, it should allow for natural or intuitive interactions. It has a higher immersion factor because you're interacting with the environment, and navigating the UI can become fun, and it's part of the experience. I mentioned it earlier, Colin, as well, but the Meta Interaction SDK has a lot of samples for this, for both methods, and for us, it was a great source of inspiration. Now, when prototyping for Maestro's interface, we noticed that the first thing that people would do when they put the headset on is look at the hand, wiggle the fingers, start poking objects, and then try and grab props in the environment. So this told us that there was an opportunity to kind of harness this intuition and build our menus around it. And we sort of call these interactions natural interactions. So they're actions that we used to do outside of VR, so that when we encounter them in VR, we know how to use them. The promise being is that the UI is comfortable to use and there's little to no learning curve for the user. With this in mind, we designed our interface around several key components. We've got a book with menus on them that behave just like a touchscreen. We've got buttons on the right that behave just like physical buttons. We've got a booklet that we can grab and give to Eric, our butler. This is one of the ways to start the game. And the other way to start the game is this ringing bell on the far right that you can spam, and it's got a very strong visual and audio feedback, which brings me to my final point. Regardless of which method you go for, remember that we're dealing with VR. User can very quickly become overwhelmed with information. The user can look everywhere and probably away from your menus. It can move their hands everywhere and probably away from your menus, and with hand tracking, you've got no haptics, and you can move every single finger. So all of these make it all the more important to make your golden paths very clear and obvious, and remember to have very strong audio and visual feedbacks. And this more or less wraps it up. Here's a sum up of all the topics I've glanced over. And I've added some tools at the bottom that you will need to, well, you will want to use. Yep. And with this, thank you everyone for listening. If you want to get in touch, don't hesitate to send us a message.
All right, so now Samuel and I would be happy to take questions. If anybody has any, you can feel free to come up to the mics. Also invite Jesse, who's my engineering partner, to come up and answer any questions in case there are any that are more on the technical engineering side. Yeah, do you want to go ahead?
Cool, yeah, absolutely. Great talk. Having used a lot of hand tracking, both in games and enterprise work, I'm trying to wrap my mind around it. I haven't played Maestro, but now I have to. So when you would do a thing, you're doing a pose detection. Is that correct? You're not necessarily saying, oh, whatever the hand does, this is exactly what I'm going to render. Instead, you're kind of specifically looking for a pose, and that kind of is what triggers the event, the input, if you will. I'm trying to wrap my mind around you saying pose detection.
Yeah, so we would so define a gesture and then list conditions and have them run at the same time. And if all conditions are true, the input is detected.
Yeah.
So, yeah. So
making this up. So for example, if I put up my hand and then I did a thumbs up, that would be an input. But if I did it this way, that wouldn't count as an input. Is that kind of what you're trying to get at?
So it depends what you do. You can detect both gesture and poses. There's a slight difference.
Okay.
Obviously, poses are very easy to detect. Well, easier to detect than gestures.
Yeah.
And it really depends on the context. For us, we both implemented pose detection and gesture detection.
Got it.
But the difference would just be one or two conditions. So if you want to detect a thumbs up, you will just detect this pose, making sure the hand is in front of you, that the fingers are laid out like this. If you want to detect the gesture of doing so, you might want to just add a condition that checks hand velocity.
Right.
And yeah,
Thank you.
thank you.
Is Meta actively developing new input navigation systems, or more looking to like the model of Gorilla Tag, where if somebody kind of proves it out in the market and in the space, that then that's something you might choose to integrate that other people could use in their production as well?
I'd say it's a mix of both. We have like pathfinding teams at Meta who are kind of trying to be the pathfinders in developing new and novel interactions that we put in ISDK, and we're also like constantly like looking outside of both what are developers doing on our ecosystems and what other competitors are doing in their ecosystems, and making sure that we're keeping up with best practices.
So if a developer were to invent a novel input system that addressed some of the constraints that you talked about with like using just hand gestures for sliding and things like that, if somebody were to solve that kind of a problem, would you look to outside developers for that, or would that first have to be proven out in a game and then you would say, okay, now we'll go to that person? Is there an open channel for looking at middleware that might be created by input system developers?
Yeah, I mean, I think it's nuanced, but like definitely there's an opportunity. Like we're looking for what you guys are learning and trying to learn from that. But it kind of depends on the use case. And I think from our perspective, we're looking at like what are the most generalizable interactions. If somebody invents something that's like really great for like lumberjacking, that might not be something that is general enough that we would like want to platformize for everybody. But if it's something that's general enough that we think a lot of developers would benefit from it, that's the type of thing that we try to lean into.
All right, cool, thanks.
Yep.
Hi, thanks for the talk. In our game Dimensional Double Shift, we've gone all in on hand tracking, and the last update for hand tracking was a big help, but still the #1 source of negative reviews for our game is the quality of the hand tracking. Is Meta still working on improving the hand tracking?
Yeah, 100%. Yeah, and I want to say Dimensional Double Shift is a great game, so folks check it out.
Thank you.
But 100%. Yeah, like we have a whole team dedicated to hand tracking, like a large team, large investment, constantly like training new data to make our hand tracking models more robust. I'm glad you noticed in V85 that rolled out earlier this year, we did like our hands version 2.4 update, which did significantly improve the quality of hand tracking. It will continue to get better over time.
Great to hear that. Thank you.
Hello, thank you for the talk. I wanted to ask, is the Meta Interaction SDK available on other non-Meta headsets? I assume anything that has an external camera could probably work, but even if you have like a non-traditional headset, could you do any sort of modifications to like still access the hand gestures?
Yeah, good question. So I know Colin mentioned this in the talk. A couple of years ago, we made a pivot. So originally, Interaction SDK was specific to the Meta runtime. So you had to be on a Meta headset for that to work for you. We still have that version of Interaction SDK, but we also have a dependent package under Interaction SDK called Interaction SDK Essentials, and that's pure OpenXR.
Oh.
So any device that can communicate over the OpenXR API, you should be able to get access to that, both for hands and controllers.
Thank you.
Hi, thanks for the talk. Our team, we are developing a mixed reality fighting game, which involves some really fierce hand movements. So my question is, what's the recommended practice for the latency problem? Because we find that for controller, usually the hand model will catch up with your hand movement, even if you are moving really fast. But for the hand tracking, it usually has a really noticeable latency, and which feels really weird, especially in mixed reality, because you can actually see your hand, and that kind of latency just is really disturbing. I don't know if there is any recommended practice, both from Samuel or from the engineering side. Yeah.
Yeah, I can chime in, and if you have any other thoughts, Jesse, feel free to, or Samuel. Mixed reality is a bit of a challenge for those use cases, and it's a bit counterintuitive because the hand tracking latency is lower than the pass-through latency. So like what you're seeing your hand is actually like behind what are like hand tracking models is detecting your hand, which is closer to the ground truth reality of where your actual hand is. So it's not actually like hand tracking being slower than your pass-through cameras. It's the inverse. We do have like some samples, more so on like the virtual reality side. We have like open source game we call Move Fast that's worth trying out, which is like our like kind of fitness boxing type experience that we built with hand tracking that you can see some of like our recommendations for how to make that work. Like one thing that we support is called fast motion mode. I don't know if you've tried that, but you can get 60 hertz hand tracking instead of 30 hertz, which is a good fit for games that do have those like really fast motion requirements.
Oh, we will check that out because well, it might have been a time before we tried the hand tracking. I'm just expressing our issues when we tried last time. That's quite some time ago.
Okay.
Thank you.
Yeah, I think fast motion mode is probably going to be the thing that helps you the best there. Also, there's a feature called wide motion mode. If you're dealing with these kind of like hand coming out of the field of view and into the field of view, wide motion mode can give you faster reacquisition of the hand when it re-enters the field of view. And the only other thing I can think of is there's an upcoming additional hand-focused OpenXR API. I can't quite remember which version it's releasing in, but it's within the next couple of versions where you can, if you want to do your own extrapolation, you can pull the unextrapolated hand poses. You can further reduce latency, but then you'll want to apply your own filtering and extrapolation on top.
Thank you.
Hi, thank you for the talk. And we are a group of students from CMU's ETC, and we developed a game based on hand tracking as well. And we also use haptic gloves to enhance our immersion. But when we developing that game, we have struggled with how to teach people to use the correct gesture to do our interaction. So I'm curious about how do you design the tutorial for teaching a player to use the correct gesture for the interaction?
Yeah, go ahead.
In Maestro, so I mentioned Eric Butler. We've got a tutorial where this character is next to you and shows you the gesture in 3D. And this has proved to be quite effective to learn a specific gesture. Okay. Then it's just more of a regular tutorial tip. It's just ensure that the user has enough as a test bed to test the gestures before actually jumping into the final gameplay. But yeah, showing the gesture in 3D is very effective.
Thank you.
Yeah, and maybe just to add one thing, but like the one of my best practices that I call that was lean into embodiment, and like I think wherever possible, design your interactions to be intuitive so they don't necessarily need to be taught. Like if you need a user to grab an object, they should just be able to reach out and do what they would intuitively do with their hands to grab that object. And that something like that shouldn't require a lot of education. So, you know, using best practices, using Interaction SDK and like using embodied interactions wherever possible, it lightens the burden of education, but doesn't eliminate it. You still need to make sure that your users are learning what they need to learn to be successful.
To add on that, because our game is designing a bit special gesture, because we found that VR expertise will grab the object just like this, but our game requires player to slowly close their palm, because we are like squishing a heart. That's our game. Or we have an expo tomorrow at the South Hall. If you're interested, you can check out. But yeah, I think that's because our interaction is a little bit special. So we will require more weird tutorial for that. So I'm just curious, like, yeah, more abstract gesture, how to.
Yeah, like Samuel said, like using like kind of 3D model animated
just
hands
teach
to
you.
show the user what they should be doing with their hands. That's a generally good practice.
Good. Thank you.
I'm curious to hear about the state of the art for testing these gestures, and especially as you're tuning the thresholds for, say, a custom gesture, without having to jump into doing a new build and constantly waiting for builds. Do you have any guidance or advice around this, either with a simulator environment or with custom tooling that you develop, say, for Maestro to help speed up this process?
So if you're testing VR, you of course have to have a headset on. You could do builds, it's quite slow, but what has proven to be the best way to do it is just to plug in your headset and use, is it Metal Link, name of the app, that just links it up to the engine, and you can preview VR on your computer as if it was a PC game, and you can get hand tracking in that scenario.
Cool. Okay, Link and hand tracking is working well for you?
Sorry?
Hand tracking Link is working well for you
Oh,
these
yeah.
days? Okay, great.
Yeah, yeah.
Okay, cool.
Well, yeah, it is.
Okay, cool.
Go ahead.
Yeah. Hi, I designed a VR game in 2019 and used the hand tracking. In this game, I have to deal with the data in the Unreal Engine to see which hands they spawn, because I want to different gesture can spawn different magical. But I have to deal with the data. I calculate which gesture the player use in the Unreal Engine. But I think future maybe the input system will be like keyboard. I can just have one. I have several choice, very simple choice, but we still have very difficult gesture, but which I can find some open library can deal with and recognize this gesture. And I want to know, I can still input this hand data, then I can deal with and calculate in the Unreal gesture. And I also want to pass through. In the Unreal Engine, I can deal with the pass-through image, because I still have some signal like LED light to put the position in the XR game. I feel it's more stable. For the O is richer, better than the richer, yes.
Okay, let me make sure I got it. I think at least one part of the question was like, basically it would be nice to have like a library of,
Yes.
of gestures versus
Yes.
having to like do that detection and recognition on the application side, right?
Yes.
To that point, I think that's good feedback for us. So we're on the same page. There are a number of like core gestures that we support through OpenXR APIs, and those are like pinching with your index finger, and then last year we added a bunch of other gestures that we're calling micro gestures. Those include tapping your thumb on your index finger, swiping your thumb to the right or to the left or forward or backwards. There are some additional gestures that we're planning on adding over the next couple of years. But I think beyond that, like the Interaction SDK is the tooling that we are investing in to make it easier for developers like you on Unity or Unreal to author any of your own custom gestures that go above and beyond those core set of gestures. I think we're further ahead on Unity than we are on Unreal for supporting those. But that's what we're trying to invest in to make that as easy as possible for developers.
But I feel now the head gesture is focused on the interact with the interface. But for the game, we interact with the object. It's very different because the catch hold is better, much user in UI interactive. So I feel it's very different aspect for the head trust library. Yes.
Maybe we should follow up afterwards in chat so I can understand better the use case in question for that one. Thanks.
So hi everyone, thank you for the talk. I'm Salar from SensoryX in Switzerland. So we developed like motion tracking infrastructure and spatial tools. And one of the things is we did the first like ring, which is a 6ToF ring, fully 6ToF using only ultrasound. So it was really done for mostly AR glasses or smart AR glasses with display. But listening to your talk, I was wondering where actually there would be utility to have this ring as a second modality of the optical hand tracking, because we don't really worry about direct obstruction. So if you don't have a line of sight, it will still be able to catch up. It's very fast. So would there be any utility to mix and fuse like the 6-stuff ring, ultrasound, and the optical hand tracking?
We should talk more later. I'd be curious your perspective on that. I think there are definitely some signals you could get from something like that that would be helpful. There's the trade-off of like that, requires additional costs for users to purchase and have that, so it may be less accessible than just using your hands without any accessories. But
Okay,
yeah.
we can talk after. We can try it at Pier 17.
Cool.
Let's talk after.
Yeah, thanks for flagging that. Go ahead.
Hello, thank you for the talk. I'm Claire Rice from Alchemy Labs. I deal with UX UI. On the accessibility front, what is your outlook for the next few years when it comes to limited mobility in hands and limited digits? Like, is there support for that coming up in the future? Because I've been on floors playtesting and have had players come up and want to just test the limits of hand tracking with just like 2 fingers and like limited digits as well. So yeah, I just wonder what your plans are on that front. That would be really encouraging to hear.
Yeah.
Even breadcrumbs.
I don't have any specific updates to share, like specifics on a roadmap. Like accessibility is something we obviously always have in mind. There are like some people who may not be able to use hand tracking in its current state because of their disabilities or mobility limitations. There are other people who cannot use controllers today, but can use hand tracking because of their disabilities. So I would say, like, going back to some of my earlier slides, if you do want to be accessible to the widest possible audience, supporting both hand tracking and controllers, I think is a general good practice to be able to cast the widest net there. But we're always looking to make both our hand tracking and controllers more accessible over time. Go ahead.
Okay, this question's for Samuel.
For who?
Samuel. So were there any sort of standout gestures that were challenging to implement? And like, what were the challenges and how did you overcome them?
Sorry, can you repeat?
Were there any specific gestures that like stood out as very challenging to like sense properly? And like, what was the challenge and how did you figure out to fix it?
Yeah, gestures that combine multiple gestures are quite difficult. We found that it's easier to break it down and keep gestures simple. So if you want to detect this gesture, for example, try and just detect this gesture and not this one, or try not to combine multiple gestures into one. I said earlier as well, it's easier to track poses than actual gestures. And yeah, that's what I have.
Yeah, thank you.
Cheers.
Hello. So if you, what we find, you give someone an object in front of them, they want to reach out and grab it, that's great. The next thing is often, I want to throw it now. The problem with that is it's outside camera range almost every time. So I'm curious if you have any like best practices or thoughts on making throwing better with hand tracking.
Yeah. Yeah, throwing's challenging. One thing to look at, so in the past year we released so we have a set of showcase samples on GitHub for Interaction SDK. We released a throwing specific sample where we showcase footballs and frisbees and cornhole bags and darts and all sorts of different throwables so that you can really test the different kind of swings that a player might take for different throwables. Most, if not all of these throwing mechanics utilize a feature I mentioned earlier called wide motion mode, which is using other parts of the body skeleton that are tracked by the camera to predict where the hand is when it's outside of the field of view and giving you that fast reacquisition when it re-enters the field of view. And then Interaction SDK has some algorithms to help deal with the lossiness of the data as the hand comes back in and you're making up for those frames trying to understand the velocity of the hand. So check out that sample. It should have the latest best practices for throwing.
I'll make the pitch also that that's one of the samples that we're going to be demoing at our booth this week. So if you come by, if you want to check out, throw a bunch of darts and basketballs, it's pretty fun. Go ahead.
Hello, I'm a USA Games student, and I'm curious about how the VR can distinguish the hand from the VR user with other people's hand, just like we are thinking about to create a multiplayer board VR game that use hand tracking, because the players with players that sit very close to each other. So I think maybe it can mistakenly that because in a VR viewer, we have the two hands in the in front of the users. But if suddenly the third hand appeared in the viewer, what will happen? Can the VR distinguish the different hands correctly? I'm not sure.
Yeah, so our hand tracking models are built using machine learning, and so we spend like a lot of money collecting data sets that are attempt to be representative of what our users might be experiencing when they have their headsets on. That's definitely like one use case that we've had in mind. I think in the early years of hand tracking, it would be we would be much more prone to be detecting a user's hands on a different user, or even like, I don't know, if I played like barefoot, it would frequently pick up my feet as my hands. I think the current models do a lot better of that. I think just with, in the black box of machine learning training, just more data allows the headset is associated like, okay, here's the arm is connecting to the hand, and knowing if that arm is coming from the user's body versus somebody else. It's getting better. I can't say it's perfect. I think you will have a better experience probably if you are not like playing Twister with a friend while doing a VR game, but it has come a ways, and it'll probably get better over time.
Okay, thank you.
Hello, I'm Hayes. I'm a student in CS and game design at Northeastern, and I was wondering if the head motion impacts the hand tracking at all. Like if you're doing a motion that involves like moving your hand side to side, and then the user's like trying to see what's around, so like might be looking over the shoulder or something. Like, does that impact the hand tracking at all, or is it like purely separate?
Like the head motion?
Yeah.
Yeah, I mean, it kind of goes back to my last answer of it's all based on machine learning training, and we tried to like make that data set as representative as possible of users' experiences. And users' experiences do involve moving the head in addition to hands. So it's I think it does pretty well. It's pretty resilient to any sort of head motion while your hands are moving. Not to say it's 100% perfect, but I'd say pretty good and always getting better.
So it's not like an extra variable you have to add on when creating the gestures. Like if the player is going to move their head, you would have to be like, oh, like head minus like arm position or something. Okay,
Nope.
thank you.
Hello, I'm a student at USC, Interactive Media and Game Design. I was just wondering a few things, especially because I recently got introduced to Meta Ray-Ban glasses, where it uses tendon sensors to like sort of do the finger tracking. So I was wondering, like, what are the factors that are preventing Meta from integrating tendon sensors for finger tracking alongside camera-based gesture tracking within Meta headset, while also having like the traditional way of how controller has interaction? And this might be like a stupid question, but I'm just like asking as a product designer point of view.
I'm not sure if I picked up the question. Is it
So,
like
I'm just
I would consider
asking,
supporting like the
why
neural
is-
wristband, or
Yeah, I'm just asking, like, why does the headset controllers not have the finger tendon tracking? Because I feel like it would be much more precise.
the what tracking?
The tendon tracking, when there's like a wristband.
Okay, the neural wristband. Yeah.
And it kind of like calculates your tendons.
Yeah, well, a few points on that. One is like the Quest has a lot more cameras and sensors than the like Ray-Ban glasses or the Ray-Ban display glasses. So like the Ray-Bans kind of need that because they don't have like the sensors that they need to be able to track it using computer vision, which the Quest does have. So like we're using computer vision on the Quest, you're able to track the same gestures that you're able to track on the Meta Ray-Ban display, without the neural wristband, which has that like accessibility advantage of you don't have to pay extra money for extra accessories or hardware. and you don't have to like put on that accessory every time you want to use your Quest headset. So the real big advantage that you get from the neural wristband is like ability to do a gesture like outside of the tracking range of the camera. You're able to put your hand under a desk or behind your back and still detect that. So there is an advantage there. You know, it's something that I think we're considering. Like I wouldn't be surprised if that's something we support sometime down the line, but it just hasn't been like the highest priority for us at the moment.
Thank you so much.
Hey, Thomas.
Hey, all right. Looks like we finished up Q&A. So I'm from Meta. So real quick round of applause for you guys. Thank you so much.